Just excuse me for a second. My screen is a bit frozen. I'm trying to share my screen here. Okay. I think my screen is visible. Please do let me know if you're able to see my screen. Hello. Can anyone confirm, please?
Yeah, I can see your screen.
Oh, great. Okay. So, hello everyone. I'm Namrata, and I'll be presenting my capstone project, which is a research-based project on a zero trust semantic middleware for MCP compliance. In very simple words, I call this system as a sentinel. So, what this actual research revolves around is a security component, which is kind of inbuilt in the MCP protocol system in terms of how secure you can build a system. I'll speak more on how I have approached this complementary security solution in terms of today's industrial usage and solutions of how MCP protocols and multi-AI agent models are utilized in the current industry solutions. This would be my agenda. I'll go through the problem statement in each section which has been incorporated as part of my research paper. So the problem statement is pretty simple. Nowadays, we are not only using a chat-based system where we are just textually interacting with a system like, hey, can you give me some information on so and so problems, give me some information on so and so solutions. But we are actually having AI assistants who do and go forward and do some active tasks on our end. So we are completing real tasks and not just replies anymore, which brings in the system where we are signing in, where we are trying to give authorization to multiple systems to the AI agents, which go forward and connect to multi agents and then perform those actions. Now, if AI agents are connecting with so many different applications on our behalf, there's some authorization part that happens. And then what kind of system are we building in terms of having complete security? And due to the recent, very much adapted solutions of having zero trust policy systems, where you don't trust a system completely, but you always verify and not just only trust. So the problem statement of this research is to build like a complementary solution in which we are trying to verify each and every action or task an AI agent um, compares or does instead of just trusting and authorizing it to do everything on its own. So what motivated me to pick up this interesting topic, which is a kind of a conjunction between security, AI agents, MCP, and a bit of machine learning concepts as well. So what motivated me to come to this conjunction is um, we are authorizing agents to do a lot of tasks. We are using assistants to perform a lot of duties. But how are we actually fact checking that there is no malicious intent leading to any unauthorized actions and access that takes place? So the motivation comes from building a zero trust architecture and not pointing to any system or architecture or labeling it as unsecure, but how best we can secure it even better is the motivation behind this research. So the background comes from the simple architecture designs of MCP, which was very recently introduced in the early 2024, where we built architectures of interacting with multiple AI agents and how the transport layer, application layer, data layer interacts with data and how session access takes place. And there's confused deputy risk, goal drift, and a lot of concepts around cosine similarity, which goes into the background research of this particular problem statement. And these backgrounds research papers are something which backs up my solution in terms of what kind of loophole or what kind of complementary solution am I suggesting to make this MCP architecture even more secure. So the related works are kind of lists all the research paper which acts as a baseline to what I have been trying to do. And all these have been cited. So anyone interested could, really go forward and check out these related research paper and understand more about the core concepts which leads to these Sentinel solution. So the synthesis matrix brings on the three major research paper which I have chosen in terms of understanding um, what actually leads to this particular Sentinel solution. So the very first one was trying to understand the threat model coverage. So understanding how attack surface can be reduced or what attack surface means. So it's like if you mistakenly leave your house door open, okay, anyone can just come in. There can be a theft, a robbery, and if you give out your key to the wrong person, again, there could be theft and robbery. But in both of the cases, one was unintentional, one was intentional, but still, the attack surface in both the cases is pretty much high. So, in similar cases, when it comes to technology as well, we have to make sure, even if we are making any mistakes or, any unintended or intended wrongdoings happen, how do we still have the capability of securing our systems? The second would be how are we building the defense layer? We all have absolute baseline security systems in place in almost every architecture that is built in the current industry. But there would always be some scopes, some ways, the unintended malicious ways can, just scope in and cause some damages to the architectural design. So I'm focusing on one particular aspect of defense layer complementary systems, which is asking the question that is my AI agent performing the same action it was intended to do? The third one would be evaluation. How am I evaluating the different metrics, the different protocol adjacent integrations with AI agents and the applications, which would actually back up my research in terms of am I really making progress by using this approach, or what are the caveats behind this, or what better can be done, and what needs to be just left behind. So the following is the feature list, which you see on the screen. So basically, I would give like a very much a overview of what I'm trying to do here in terms of features. So basically, as I said, what I'm trying to solve the question here is my intention aligned with what the action is taking place? So if I have to give a very simple example, if I am in a banking system and I have to check the balance of my account, my intention in that session is to check balance of an account. But in case after the session authorization, there's some malicious prompt injection takes place and the AI agents actually interact in terms of performing an action of moving your account funds to some other account. That is something that deviates from the intent. So when it comes to the TCP layer of OSI model, your TCP layer just focuses on zeros and ones and bits. We don't understand the intent behind what's actually should be done and what is happening. So the feature list focuses on registering your goal registration, having role-aware embeddings, and then having the semantic checks, and then doing all the metric evaluation and trying to understand how we bring down such attack surfaces in such malicious actions. The approach is pretty simple. The first one would be having a goal registration in terms of what the intention of the session is. So if I want to check the account balance, my goal of the particular session would be to check the account balance. And how do I store this? Not in terms of words, but of course embeddings. So we store the embeddings of all the intentions, and um, then our different layers of security systems would go and check if this particular action that the AI agent is performing is actually aligning with it or not. So in this particular approach, I have chosen three different baseline models. The first one is control, which doesn't have a single baseline security model in place. So it doesn't do any fact check or any um, word check in terms of whether this is malicious or not. The app layer, which you see, would have like the basic guardrails in place, which would check like harmful words or something that should not be allowed to process and stuff. And the Sentinel is the final solution, which I am proposing in terms of the intent or the semantic evaluation that needs to be done. The step five would be to have the role-based user access check as well. So every user who is assigned to any particular section would have a role assigned to him, to her or him, as of what kind of access do you really have in terms of performing certain actions. So these all approaches brings down to all the metric evaluation that you see in the last steps. So we have like an exhaustive log system which actually evaluates and marks all the values of the embeddings, and then we would go through the findings and so on. So whatever approach I have shared, this process flow diagram flows through the entire process. The solution architecture is kind of putting together all the input layers, the semantic interception, and how the audit logs help us evaluate all these solution architecture. The implementation is particularly the implementation plan of all the three agents, which I just discussed. For the data collection part, I have a synthetic data set which has been created using 1,000 prompts. So in any real world industry solutions, the 5% of the data is skewed. So I have like a 5% data which is malicious, and the rest would be the benign data set. So the skewed data set is being evaluated based on the three different baseline models, and then the metrics have been evaluated. The data analysis have been done on these particular characteristics where I have went through the evaluation based on binary outcomes, the latency differences, the sentinel similarities, so your false positive rates, recalls, F1, precision scores, and so on. So this is just a comparison of all the findings which I've got in terms of all the metrics. And for the findings, I would most probably go to the demo and then share it through this. The future work kind of brings in picture of like how multi-access or cross-session browser things happen. And there's a lot of scope in this particular research, but it gets kind of tricky in terms of how external validation and monitor distribution takes place. So all the listed future works are, in depth and in its own a very huge research work on its own. These are just the bibliographies on based on the research which I've used. Now moving forward to my demo. So this is the dashboard which I have in place as part of the prototype. So as I mentioned, I have 1,000 data set prompt um, in place where I have like a 5% of skewed data, which is malicious, and the 950 is the benign one. So this particular dashboard just evaluates how each data set was evaluated on three different models and whether they were blocked or not. So for example, when I come to the execution trace, all the 1,000 prompts have been logged in this exhaustive execution trace, where you see if it's a benign prompt, it should be executed by the MCP agent. But if it's a malicious one, it should be blocked. So, in terms of understanding that were all the malicious prompts blocked, then I would say, as part of the accuracy or the findings part, only 48 out of 50 were blocked in terms of having just role access based in place. But two of the malicious prompts were blocked in as part of the Sentinel solution in place, where it actually fact checked the intent of the goal versus the action that was taking place. So I present the Sentinel solution as a complementary architectural security, which does not question an architecture if it's not secure enough, but with a approach of how do I make it even more secure. So if you click on any of the prompt IDs, you get the exhaustive JSON evidence on checking of how and what was checked, what was found, why was it blocked, and so on. And you see all the latencies, all the success, positive rates, and everything being logged so that we are not just doing a predictive analysis, but this is a very deterministic approach in terms of understanding why a certain thing was adapted. So every log would have its own authorization trace and exhaustive metric evaluations. And the final dashboard part is the metrics and comparison, where you see the comparison between the three baseline models of having a control system in place, the app layer, and the Sentinel, and why I present Sentinel as complementary approach in terms of having security in place. Yeah, so that's it from my end. If you guys have any questions, I'm open to questions. Anyone has any questions? Okay, I think I take the silence as
Oh, Namrata, I had a quick question if you don't mind.
yeah, yeah, please, sure.
So I may have missed this at the beginning, but like as
Mm-hmm,
you were designing your architecture to
mm-hmm,
evaluate, like whether or not um, a command was malicious or not, like
mm-hmm,
how I know like as you get into like more complex like actions that the AI is going to be taking, it
mm-hmm.
gets just more layers in there. Did you
Yeah, true.
see did you see like a level like how did you take that into account as you were designing your system, I guess?
That's a very good question. So, this comes very core to how security works in terms of zero trust architecture. So, as I've always been mentioning, why do I choose checking intent? Because there is no current guardrails in the industry which actually checks intent. Because firstly, at the TCP layer, it's all zeros and ones, it's bits. So you actually won't even understand if an AI agent is connected to a different architecture or application, if it's actually intended to do it or not. So I'm suggesting this as a complementary security solution because I won't say like it's bringing down something drastically, some drastic changes in terms of security, but it kind of drives the secure zero trust secure policy. So, and in terms of going through all the baseline models, like checking all the data set against all the metrics, I saw how two or three malicious prompts, which were not just blocked by role-based access. So if your role-based access is in place, they will be blocked. But there's always a loophole which can be prevented, bringing such security models in place. So this is something which is complementary, and this is something which is a very fresh perspective in terms of checking intent, is what I feel.
Yeah, and then just to follow up on that, like when you're talking about intent,
Mhm.
are all your prompts, do they all have like a singular intent? Or is this work as well for situations where there'd be like multiple things that the AI would do? Like You use the example of like a balance transfer, but could you do would a command that had like some intense could you make the malicious um code to be kind of like recursively inside another intent?
Yeah,
I Okay.
yes. Yeah, so of course, a session goal cannot be static. So not every time you're going to have the same intent of doing a particular session access, right? So it has to be dynamic. It has to be registered every time you authorize yourself as a session user. And then it should be checked against your actual action that is taking place between the MCP layer and your AI agent connecting to a different application, right? So it has to be checked at every single point when an AI agent is trying to connect to a different application. So your session goal should be dynamic. It should never be static and same.
Okay. Well, thank you. That's awesome. Great work.
Yeah. Okay. Thank you. Okay. I'll just